Assalamu alaikum. The second transformation that we are going to do today is the reflection, and we can see that the reflection can be done along the x-axis and it can happen along the y-axis also. So how to differentiate between the two axes reflection? Let's go ahead and see that. So for reflection along the x-axis, we can see that whenever we have a negative sign outside the function, we say that it's going to reflect along the x-axis. But if we have the function as f of minus x, then we say that it is going to be the reflection in the y-axis. So these are the two function differentiation for the reflection along the x-axis and y-axis. X-axis, it has to be, the negative sign has to be outside the function, and for the y-axis it has to be f of minus x. So let's do an example to see how we can just transform for the reflections here. Now let's say our fx is equal to x bracket x plus 1 bracket x minus 2. So what we observe here is that for this one we have x into x into x. If I just multiply the three x's, I can see that it's going to be an x cube. That means it is a cubic polynomial that we have here. So the question says for the function x bracket x plus 1 x minus 2, sketch the graph of the following functions. Part A, it's 1 plus f of minus x. So look at the difference between the two. For part A, it says f of minus x, meaning this needs to be reflected along the y-axis. For part B, we can see the negative sign outside the function. That means this needs to be reflected along the x-axis. So let's look at the solution for part A first. It's the function which is x bracket x plus 1 bracket x minus 2. So as discussed earlier, if I multiply the three x's, I'm going to have an x cube, meaning we are pretty much sure that it is going to be the cubic polynomial. Now this x equated to 0, that will give me x is equals to 0. If I equate x plus 1 to 0, then our x value is a negative 1. If I equate x minus 2 with a 0, my x value is going to be a negative 2 here. So this is what we shall be doing. It's x bracket x plus 1 x minus 2 is equals to 0. We are equating it to 0 to get the root of the function, meaning the x-intercepts of the function. Therefore, x is equals to 0, x is equals to minus 1, and then x will be equal to 2 here. So these are the three roots that we should be having for the function. Next about the cubic polynomial is if the coefficient of x cube is greater than 0, then we should know that the shape of the graph has to be this kind of wave, where first we should be having the maximum turning point and then I should be having the minimum turning point here. So this is the shape of the graph whenever our coefficient of x cube is a positive, meaning it is greater than 0. If it is vice versa, meaning the coefficient of x cube is a negative, meaning it's less than 0, then the shape of the graph is just the opposite. First, I should be having the minimum turning point, and then I should be having the maximum turning point here. So this is the basic thing that we should be knowing about a cubic polynomial. So applying this concept to the given function, I can see that x into x into x, that is just an x cube, meaning the coefficient of x cube is a positive. Therefore, I know that the shape of the graph has to be such that first it should be the maximum and then it should be the minimum turning point here. So for the function, we have found the three roots: x is equals to 0, x is equals to minus 1, and x is equals to 2 here. So these are the three roots that we have for the function. So with respect to the three roots, we can very easily sketch the cubic polynomial. And for that, we have seen x equals minus 1, one of the root. It's here, x equals minus 1. Then it was x is equals to 0. It's this point. And then we have x equals to 2. It's this point here. X cube is a positive, has a positive coefficient. Therefore, the shape of the graph is such that between -1 and 0, between -1 and 0, I have the curve so that it's first maximum and then it should be having a minimum value here. So at least I have the shape of the graph for the given polynomial. Now for this function, part A says sketch the graph for f of x so that it's equal to 1 plus f of minus x. So this one here means that it is the translation in the y-axis. We know from the previous video when we did the transformation for translation that the constant in the function or the equation is always going to give us the translation along the y-axis, meaning how the graph or the sketch or the function is going to shift in the vertical direction. So plus 1 here is a constant, therefore I know that it's going to be the translation in the y direction, so that the vector here is going to be 0 and 1. F of minus x means it has to be the reflection in the y axis here. So let's start the transformation. So for the transformation, I had the graph, the basic graph of the function drawn in pink, which was having the roots as -1, 0, and then a 2 here. So if I need to reflect it in the y-axis, 0 on the y-axis, that will be invariant. So it will remain where it is. It's on the y-axis. What I can see here is that this point, this graph here, it should get reflected in the y-axis so that I have drawn the sketch over here. This point gets reflected in the y-axis. Again, the minimum point gets reflected in the y-axis, so this point comes here. The whole of the graph, this graph reflected in the y-axis, can be sketched on the other side in blue so that I know that after reflection, the graph has come to be of this shape. After that, I should be having the transformation with respect to 1. That means it's a vertical transformation along the y direction in the positive, because 1 is a positive here, so it needs to get shifted upwards. So shifting it upwards, it's just the blue curve that I shall be having here. From 0, it was initially at 0 here. So shifting it by 1 unit, it has moved to 1 unit here. -2 also, it should be moved by 1 unit. From 1 also, it has moved, which was the root of the function after the reflection in the y-axis. This has also moved by 1 unit. So I've just shifted the graph by 1 units upwards, so that this is how my graph is going to be. So this is how we do the reflection, and it's a composite transformation having translation as well as reflection for this case. So let's do part B. It's the same function f of x, which is equals to x plus 1, x minus 2, the same function, the same cubic graph that we already know, have sketched earlier. But now it should be sketched for the transformation which is negative. There is a negative outside the function, meaning now it should be getting reflected along the x-axis. And then within the bracket, it says it's negative fx plus 3. So what I know here is that f of x plus 3, that shows a translation in the horizontal direction, so that the translation is going to be -3 and a 0. It should be translated horizontally towards left. And with the negative outside the function, it should be reflected in the x-axis. So this is the major graph that we have, the basic graph that we have regarding the function, which is x, x plus 1, and x minus 2. So if I need to translate it by 3 units towards left, then what I should know is that this point 0, after shifting towards left by 3 units horizontally, it should come to negative 3 here. This 2 again should be translated by 3 units towards left, so that it's going to be 1, 2, and then negative 1. So this 2 gets shifted to negative 1. And then same will happen to negative 1, shifted by 3 units, so it should be negative 2, negative 3, and then it should be a negative 4. So what I know here is that my reflection after the translation along the x-axis is a negative 4, negative 3, and a negative 1. It is the transformation regarding the translation in the horizontal direction by negative 3 units. After that, I should be reflecting it along the x-axis. So if this is the graph after the translation along the x-axis by negative 3, then just reflect it along the x-axis. This point, this curve gets reflected here, this part gets reflected upwards, and I can see that this part of the graph gets reflected downwards along the x-axis. So finally, this is the transformed function that I will be obtained after the two transformations. Number one, the translation, negative 3, 0, and then the reflection in the x-axis. So this is going to be my final sketch for the two combined transformations here. Let's do the second question. The graph of y equals fx is transformed to the graph of y equals f of negative x plus 7. So describe the transformation. So to describe the transformation, it's very much clear that we have a negative x, that means it should be reflected in the y-axis, and then there is a positive 7, meaning it has to be a vertical translation by 0 and 7. So this is how I will just be defining or describing the transformation, the composite transformation, once for reflection in the y-axis, and then it's the vertical translation by 0 and 7. Let's do another question. The curve y is equals to 3x squared plus 2x minus 8 is reflected in the x-axis. State the equation of the reflected curve in the form of y equals ax squared plus bx plus c, where a, b, and c are constants. So this curve here should get reflected in the x-axis, and we know that whenever a curve gets reflected in the x-axis, then the function should be having a negative sign outside the function here. The negative sign outside the function has to be there for the reflection in the x-axis. So state the equation of the reflected curve. So to get that equation, I am just multiplying the entire equation with the negative sign, so that finally my reflected function shall be having the equation as minus 3x squared minus 2x and a plus 8. So this is how I will be making the equation of the reflected curve in the form of y equals ax squared plus bx and a c here. So this is going to be the answer. So this is all about the transformation, the two transformations that we have done up till now. Number one, it's the translation, and number two, it should be the reflection in the x-axis as well as in the y-axis. So the second video will be for the third type of transformations.